How big is the universe? For centuries, humanity has gazed into the night sky, asking that very question. We've marveled at the stars, the planets, the distant galaxies, always wondering, what lies beyond? How far do the stars stretch? What secrets do they hold? From ancient civilizations using rudimentary tools to chart the heavens, to today's cutting-edge space telescopes, this quest for knowledge has been relentless. But now, with the launch of the James Webb Space Telescope, JWST, humanity has entered a new era of cosmic exploration, where the boundaries of what we know are being pushed further than ever before. A new dawn in space exploration, The James Webb Space Telescope is not just another telescope. It represents a quantum leap in our ability to see and understand the universe. Imagine peering through a fogged window your whole life, and then suddenly someone hands you a pair of high-definition glasses. That's what Webb has done for space exploration. Launched on December 25, 2021, Webb is positioned at the second Lagrange point, L2, about 1.5 million kilometers away from Earth. It's a vantage point that allows Webb to stay in line with the Earth and Sun, providing it with a stable environment to peer deep into space. With its enormous 6.5-meter wide mirror, 3 times the size of Hubble's, Webb is designed to capture faint infrared light from the farthest reaches of the universe. But why infrared? Infrared light allows us to see through cosmic dust, revealing objects and phenomena previously hidden. It's like having X-ray vision for the universe, cutting through the veils of gas and dust that obscure star-forming regions, nebulas, and even distant galaxies. Unlike Hubble, which primarily views the cosmos in visible and ultraviolet light, Webb can capture the glow of ancient galaxies formed when the universe was still in its infancy. This marks the beginning of a new chapter in astronomy, one that allows us to study the universe's earliest moments as if we're time travelers witnessing its birth, revealing the hidden universe. When Webb's first images were released, the world stood still in awe. One of the most iconic images was a new view of the pillars of creation in the Eagle Nebula, a region where new stars are born. The level of detail was astonishing, revealing fine structures in the cosmic dust that had never been seen before. The colors, the textures, the clarity. It was as if we were seeing the universe's canvas for the first time. But these images aren't just visually stunning. They're a treasure trove of scientific data. Every pixel tells a story. Webb's ability to capture the chemical signatures in these stellar nurseries helps us understand how stars and planets form, how they evolve, and potentially, how life itself emerges. Webb is not merely observing distant objects. It's uncovering the processes that govern the universe at the most fundamental level, uncovering the mysteries of the expanding universe. For decades, we've known that the universe is expanding, thanks to the work of astronomers like Edwin Hubble in the early 20th century. But this expansion poses new questions. How fast is it happening? What forces are driving it? And why is it accelerating? Enter the James Webb Space Telescope. Webb's ability to observe extremely distant galaxies gives scientists the opportunity to measure how fast these galaxies are moving away from us. With this data, astronomers can refine the Hubble constant, a number that describes the rate of the universe's expansion. But it's not just about how fast, it's about why. At the heart of this mystery is dark energy, a strange and invisible force that makes up roughly 68% of the universe. Imagine the universe as a balloon. When you blow air into it, the surface of the balloon expands. Dark energy is like the air inside that balloon, pushing everything outward. But unlike the air in a balloon, dark energy is elusive. We don't know what it is or how it works. Webb is giving us critical clues, revealing how dark energy influences the universe on a cosmic scale. A glimpse into the cosmic dawn. The story of our universe begins with the Big Bang, around 13.8 billion years ago. But after that explosive beginning, the universe went through a period of darkness. There were no stars, no galaxies, just a hot, dense soup of particles. This period, known as the Cosmic Dark Ages, lasted for hundreds of millions of years until the first stars began to ignite, sparking the cosmic dawn. Webb is now able to peer back into this era. It's like looking through a time machine, seeing the universe as it was over 13 billion years ago. Already, Webb has spotted some of the earliest galaxies, shining just 300 million years after the Big Bang. These young galaxies are surprisingly well-formed, which challenges our understanding of how quickly galaxies should have evolved. These discoveries are rewriting what we thought we knew about the early universe. How could galaxies this massive exist so soon after the Big Bang? How did they form so quickly? Webb's observations are forcing scientists to rethink the timeline of the universe's infancy and the processes that governed galaxy formation. Searching for life beyond Earth. For centuries, humanity has asked the question, are we alone in the universe? The search for extraterrestrial life has been one of the driving forces behind space exploration. With Webb, that search has taken a major leap forward. One of Webb's key missions is to study the atmospheres of exoplanets, planets orbiting other stars, to look for signs of life. By analyzing the light that passes through these planets' atmospheres, Webb can detect the presence of certain chemicals like water vapor, carbon dioxide, and methane. These are the building blocks of life as we know it. Already, Webb has observed exoplanets in the habitable zones of distant stars, regions where conditions might be right for life. Imagine a distant world with oceans and continents under a different star's sky. We are on the brink of detecting whether such worlds might actually harbor life. Every exoplanet Webb observes brings us one step closer to answering the question. Is life common in the universe, or is Earth truly unique? The black hole frontier. Black holes are among the most enigmatic objects in the universe. These cosmic giants have such intense gravitational fields that not even light can escape their pull. Webb has begun to unravel their mysteries in ways we've never seen before. Webb's high-resolution infrared imaging allows it to observe the supermassive black holes that reside in the centers of galaxies. It's capturing the accretion disks, rings of gas and matter that swirl around black holes at incredible speeds, generating immense heat and light. Webb has also captured high-energy jets spewing from these accretion disks, some stretching across entire galaxies. These jets are like cosmic geysers, and they play a crucial role in shaping the galaxies around them. What's even more fascinating is that black holes are not just destructive forces, they can also trigger the formation of new stars. Webb is helping us understand this delicate cosmic balance, where the forces of destruction and creation are intertwined. Mapping the cosmic web. The universe is not a random collection of galaxies floating in space. Instead, galaxies and galaxy clusters are strung together by an invisible structure known as the cosmic web. This web is made up of dark matter, which, while invisible to us, exerts a gravitational pull on galaxies, keeping them in place and shaping the large-scale structure of the universe. Webb is mapping this cosmic web in unprecedented detail. By observing distant galaxy clusters, Webb is helping scientists piece together how galaxies are distributed throughout the universe and how they have evolved over billions of years. It's as if Webb is tracing the skeleton of the universe, showing us the underlying structure that holds everything together. The journey ahead. The discoveries made by the James Webb Space Telescope so far are just the beginning. In the coming years, Webb will continue to observe distant exoplanets, map dark matter, and peer deeper into the farthest reaches of the cosmos. It will work alongside future missions like the Nancy Grace Roman Space Telescope and the European Space Agency's Euclid Telescope, providing complementary data and furthering our understanding of the universe's most profound mysteries. As Webb continues to push the boundaries of what we can see, one thing is clear. The universe is far more vast, complex, and awe-inspiring than we ever imagined. Every image, every discovery, brings us closer to answering the most fundamental questions about our place in the cosmos. The adventure has only just begun, and with Webb as our guide, the future of space exploration is brighter than ever. Stay tuned. The universe has more secrets to reveal, and we're only scratching the surface.